Well, I hope this works. All right, today we are learning about the greatest common factor, also known as our GCF. So, what does greatest common factor mean? It is the biggest shareable factor. And remember, factor is smaller. So think about the numbers 24 and 36. So the factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. The factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. So comparing those two lists, what is the biggest thing that they share? So, look, there it is. They both share a 12. That is the biggest number that goes into both of them. So the greatest common factor of 24 and 36 is 12. So now, continuing, now we have expressions and polynomials. So we have 18x cubed and 12x cubed. So what is the biggest integer that goes into both of those evenly? So if you want to make a list of 18, make a list of 12. So the factors of 18, 1, 2, 9, oops, forgot 3, 6, 18, ran out of room. And for 12, 1, 2, 3, 4, 6, 12. Well, the biggest numbers that they share are that 6. So 6 is the biggest number that goes, or largest integer that goes into both of them. And then it says, find the degree of x that can be divided into each term. So thinking about 18x to the 6. X to the 6 means it has 6 x's. So if we want to write that out to visualize it, 6 x's. So it's 18 with 6 x's, and 12x cubed means it has 3 x's. So it's saying, how much can I take? So when you're factoring, it's the opposite of multiplication or distribution. It's dividing it out. So you can only ever take the one that the smallest thing has to share. So I can only take 3 x's from 12 because it only has 3 x's to give. Therefore, I can only take 3 x's from each piece. So x cubed is what I can take from each piece because the 12 only has 3 of them. So the greatest common factor of a polynomial is the greatest integer and the highest variable that will divide evenly into each term of the polynomial. So, for these problems, it says find the greatest common factor of the following. So I have 7x squared and 21. Now, when you're doing these problems, I would always check the smallest number first. So 7. Can 7 go into 21? Well, yes, it can. So 7 can go into 21 and itself. And then look for the smallest amount of variables. So they both have x's, so I know I can take an x. This one has 2. This one's got 1, so I can only take 1 from each. So 7x would be my GCF. Now, for B, they both have x's, they both have y's, but looking for the smallest one. This guy has 5, second piece has 4, so I can take 4 from each. This one has 3, and this one has 4, so I can only take 3 from each. So that would be my GCF for those two. And now I have 3 terms. So if you want, maybe pause the video, try this one, or let's just keep moving. Look at the numbers. The 9 is the smallest number, but 9 cannot go into 12 and 15. So let me think of factors of 9. Well, the factors of 9 are 1, 3, and 9. Well, 3. 3 goes into 12 and 15. So 3 is my number. Now look at my variables. They all have y, so I know I can take some. Now I look for the smallest amount. Smallest amount is right here. He's got 3, 4, and 5, so the smallest amount is what I can take. All right, now what we're going to do is continuing to do GCF, but we are going to, like I said, we're doing the opposite of distribution. We are factoring out. So distribution, we multiply. Factoring, we divide. So we are still going to be finding that GCF, but then we're going to divide all our terms by our GCF and write our answer as a product. So I have 18x cubed plus 27x squared. 18 is my smallest number, but it does not go into 27. So think of factors of 18. 1, 3, 6, 9, forgot the 2, biscuits, 18. Now looking at 27, what numbers can go into 27? Well, 18 can't, 9 can't. So 9, and then, okay, check. Does both terms have x's? Yes, the smallest one, x squared. So this right here is my beautiful GCF. Now we want to actually finish the problem. So how you do this is you take each term and you divide it by the GCF. So 18 divided by 9 is 2, and when I divide, my exponents subtract. So that's why it would be x to the first, or just x. Keep the plus there. 27 divided by 9 is 3, and then the x squareds would be gone. And this whole thing, very important, is my answer. Not just the GCF. If you just do the GCF part, you haven't finished the problem. And what is cool about GCF is that I can redistribute it to check myself. So if I redistributed this, that would give me 27x cubed plus, biscuits can't do math. Whoopsie. Lied. Just making sure you're paying attention. That would give me 18, biscuits. There we go. 18x cubed plus 27x squared. And then, amazing! It is the exact same thing. And that's what it should be. So you can always check yourself on your GCF problems by simply redistributing. Okay, flip the page. How do I make this move? Biscuits. Oh, biscuits. Now I'm in a pickle. I need this paper to move. 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 Oh, I figured it out. Sorry. Well, that was fun. Okay. If you flip the page over, we just have more practice problems. So again, this might be a good time where you pause the video and see if you can do some of these yourself, or just keep following along. So on number 1, we're looking at 5x squared plus 30. So always check with the number first. 5 is the smallest number. Can 5 go into 30? Yes, it can. Woohoo! So that would be my number I can divide out. Now, does each piece have x's? No, that 30 has no x's, so it's going to, I can't take any x's out because 30 has nothing to give. So 5 is the GCF, and I'm dividing each piece by the GCF. So 5 divided by 5 would be 1, or I can just leave it as x squared because that term is there, plus 6. And then that's finished. 16x to the 5th minus 12x to the 4th. 12 is the smallest number, but 12 does not go into 16, so list out the factors of 12. 1, 2, 3, 4, 6, 12. Okay, we know 12 can't go into 16. 6 can't go into 16. Winner! 4 can go into 16. And then they both have x's, so I can take some. This guy's got 5. This guy's got 4. Take the smallest amount. So that is my GCF. Now I'm dividing each piece by that 4x4. 16 divided by 4 would give me 4. I'd have 1x left, minus 3, no x's left, boom. Another way to actually check yourself too is when you look at the parenthesis part, that has nothing in common. 4x and 3 have nothing in common, so you know you took the greatest common factor. And same with x squared and 6. They have nothing in common, so you know you took the GCF. Here, 6 is the smallest number. Can 6 go into 18? Sure can. Can't take any x's. For this one, 9 is the smallest. 9 can go into 45. And again, if this is going too quickly, you can always just pause the video. And then 12. 3x3 plus 2. All right. For this next part, it says PS. If the leading coefficient is negative, you must factor it out. Technically, will bad things happen to you if you do not factor out? No, but you might get the problem wrong in the future, so it's best just to follow the advice. Factor it out, get rid of the negative. So make that positive, make that first term positive. So see how it's negative 2x to the 4? I'm going to factor out a negative 2 and pretend this m said x, because that would make life a lot easier. And I'm going to take an x out too. Yay! So that'll become a positive x3 minus 7x plus 3. Sorry, ran out of room on that one. This guy, I'm going to take out a negative, negative 5. I can take 1x and 1y. So that would be x plus, biscuits lied. Just kidding. X minus 7. And then here, the only thing I can factor out when they have nothing in common, everything is divisible by, you guessed it, 1. So I'm just going to change all the signs. And that is factoring with GCF. Yay! Yay, math. Time for homework. Yay! Now, how do